हाँ 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 बिल्कुल हेलो हेलो आमिर खान हेलो आमिर hi Amir yeah let's talk on phone I'll call you
Sure.
Good evening, everyone. We will wait for some time. We have 38 people joined, but we'll wait for some more time for others to join, and then we'll start. So please bear with us for 5 minutes.
Okay, sir. Good evening, sir.
Yeah, good evening. Did you get the link and the 3 profiles? एक दोनों में से कुछ भी नहीं मिला. PRANJU Rathod 8@gmail.com, correct? Profile you got it. So after the profile, you'll get a link also by a separate email. So you can first join, you can go through the profile, you can shorten it if you want, and then you
Hello, Vora sir, am I audible?
Yes, Pranjal, you are audible. I'll just share the slide.
Okay, sir.
So are you able to see the slide full screen?
Yes, sir, it is visible. Yes, sir.
Sure. So you can start and then you can give the introduction. And these are the three profiles. Please
All right.
start.
Okay, so good evening to everyone. This is Pranjal, and we are here for today's BAJA India 2026 Namtex Manufacturing Excellence Award session. I'm here to introduce our speakers for today. Going forward, we'll be having Mr. Vora sir, who is the director programmer Program Director, Automotive COE at Namtech, Gandhinagar. He has completed his BE Mechanical Engineering from BVM, Masters in Automotive Engineering from VGTI, and has a PhD from IIT Bombay. He has a very vast industrial and academic experience of 40 years. Dr. Vora has started his career in 1985 at Walchand Nagar Industries at Satara. He was responsible for introduction of EMITC's metallic catalytic converter in India and also worked on Scorpio project in Mahindra and Mahindra. He's a consultant to ASDC and chairs ASDC expert group of electric vehicles. Dr. Vora has superannuated from ARAI in 2021 as a senior director and a head of ARAI Academy. Besides Professor Emeritus at COEP, he took an additional responsibility of COEP's TBI Bhau Institute of CEO for a couple of years. He was professor of practice at Raisoni College, Chitkara University, and BV Raju Institute of Technology, and consulted many educational institutes in strategy and diverse operations. Dr. Vora is an active member of ISTD, ASM, and SE India, and also a recipient of ISTD Best Learning and Development Awards and SE Foundation of Guru Award for his contribution to the students of India. Besides initiating and taking care of educational initiatives of ARAI for 17 years, he has conducted BAJA India from last 18 years. He has a total of 120 technical papers, 4 books, and 4 patents to his credit.
Thank you. Thank you,
For,
Pranjal. Thank you very much. Yeah.
for the next speaker, we have Mr. Ujjwal Modi sir. He is a senior lecturer at Namtek Gandhinagar. He has completed his BTech Mechanical Engineering from Ganpat University, Masters in CAD/CAM from Gujarat Technological University, and a PhD from Ahmedabad University. Ujjwal Modi sir has more than 10 years of academic experience. His research interest is in AIML in manufacturing, precision engineering, and metal additive manufacturing that works based on a friction as joining material. He is also proficient in various softwares including AutoCAD, SolidWorks, Fusion 360, Inventor, iScan, Ultimaker, Cura, and ANSYS. His areas of expertise as a teacher include curriculum creation, teaching pedagogy, and examination. As a subject matter expert in mechanical engineering, he effectively mentors undergraduate and graduate projects, planning training courses, and participates in scholarly investigations. He has 2 patents to his credit.
Thank you. Thank you.
Next speaker, we have Dr. Sankata Tiwari, sir. He is a researcher specialized in additive manufacturing of metal and ceramics. He has submitted his PhD thesis in mechanical engineering at the Indian Institute of Technology, Varanasi. His academic journey includes a MTech in metallurgy engineering from IIT BHU and BTech in mechanical engineering from UPTU Lucknow. His research interest also includes the application of AI and image processing in defect prediction during AM processes, aligning with the principles of smart manufacturing and Industry 4.0. He has published a total of 5 papers in international journals and has filed 2 patents for his credit.
Thank you. Thank you,
Thank you.
Pranjal.
Thank you, sir. So these are all our speakers for today's session. Uh, Over to you, sir.
Yeah, thank you. Let me switch on my camera. Am I audible and are you able to see me, Pranjal?
Yes, sir. All clear, all clear.
Okay, thank you. Thank you, everyone. And thank you, Pranjal, especially for introduction, all the three speakers. So I would start with my presentation, and after some time, Mr. Ujjwal Modi will give his presentation. And then once again, I would do the presentation. At the end, my colleague Sankata Tiwari will give the presentation. We have around 90 slides and we have around 2 hours. We are going to talk about the manufacturing excellence, the award which has been constituted by NAMTEC in this year. What I'm going to do is that before I talk about the manufacturing excellence, quickly I will talk about NAMTEC and why we have sponsored this manufacturing excellence award. So you all must have heard various news. Our Prime Minister says that we are all moving towards Vikasit Bharat, and in 2047 we will become a developed country with 600 million jobs, and our GDP in real terms will be more than $20 trillion. So it will become a $20 trillion country, and the per capita income would be our $12,000. This is also very important to know that our Prime Minister has said by 2047 we will become energy independent. That means we will stop buying any energy from outside, whether it is in the form of an electricity or whether it is fuel like crude petroleum or anything. We will become energy independent. So in short, every factory, every house has to become energy independent. The next stage is 2070, where we are talking about net zero Bharat. That means today we are the largest one, the third largest carbon emitter. We produce a lot of carbon dioxide in such a small place. And if you want to reduce this, we will have to do a lot of change. We have to bring in circularity, we have to bring in sustainability and reach towards net zero status in 2070. Other countries like US and Europe have decided to reach net zero by 2060, but we have decided by 2070 since we will take some time. One of the reason is that 80% of the India of 2070 is still to be built. We are all living in old India, and very soon so many smart cities are going to come up, smart cities with smart mobility, and that is the one which will talk about Vikasit Bharat and Net Zero Bharat. So let us look forward in the next few decades how India is transforming itself as a developed country with zero carbon dioxide emissions. And it is also important that if we need to grow as a $20 trillion company, then we have to increase our contributions toward GDP in manufacturing. Today, it is only 17% is of manufacturing contribution towards GDP of the nation. If by 2047 it is expected this manufacturing contribution towards nation GDP would be 25%, and that is possible if we are all able to talk about Make in India, Startup India, and many people start producing, not just working as an employee. So yes, there is a very positive government enablement from the government side. It's talking about Skill India, Make in India, Atmanirbhar India, and our democratic dividend is helping us because our population is very young. 68% population of working age enabled by inclusive training and skilling. And also now women have started working and we are also supporting them. So that's how our workforce is going to increase. So with government support, with this democratic dividend encashment, and with this sustainability focus, we are very sure that we will be able to become a developed country by 2047 and net zero target achievement by 2070. Let's look at what is happening at the education landscape. You will see that in this last 7 years, we have been trying hard and we have been able to enroll more and more students into education. There was a time when there are many who were not educated. Girls were not educated, they were not sent to schools. Boys were educated, but then there will be dropout at 8, 9, 10th class. So from 2014 to 2021, this has increased from 3.4 crores to 4.3 crores, which shows the student enrollment has rose to 26%. So this we define it by gross enrollment ratio, GER. So today our current GER is around 30%. That means 30% of the young population only goes to schools and colleges. We want this to become 50% by 2035. And this requires doubling the capacity while maintaining quality during expansion. So we want more schools, more colleges, more engineering universities, and so on. And it's not only the quantity, the quality is also important. Today, only 42.6% of the Indian graduates are employable. So many of them, many of us are doing engineering, but we don't have the knowledge which the industry needs, and hence we are not employable. We want more. Can you all everyone put yourself in mute only until you are speaking, please? I'll request everyone to put yourself in mute. Is there any problem? Okay. So we also want good quality students coming out. So one is the employability and the knowledge related to be industry ready. And second is proficiency in soft skill. Our communication skill has to be good. Our teamwork has to be good. Our critical thinking has to be good. This is also not there. So how do we improve that? Yes, BAHA is one such aspect, BAHA, Supra, Epicycle, where we are able to inculcate good engineering skills and make students more industry ready and also improve their soft skill. But we need to do a lot. Just BAHA has built up till now 1.25 lakh students, but there are crores of students whom we have to work on. How do we do this? Today, most of the students are going into arts, science, commerce. Only 11.8% of the students are going into engineering. We need to increase this. And that too, when we say engineering, it is civil, mechanical, electrical, computers. We also need people who can work on AI, data science, semiconductor, industry 4.0. And that is all what we need to teach and ensure that we move ahead in towards Vikasit Bharat. So it is now very important to understand that futures of India's higher education lies in its ability to shift from degree creation to capability creation, turning scale into true skill. So it has to be done on a very big scale. And it's not just degree creation, it is capability creation. Our student must be industry ready, or they can become a startup and start their own industry and give jobs, right? So that's where we will see that how factories can become smart, and how can we transform these smart factories through various aspects, like we use energy management to become sustainable. We use real-time information management. We use intelligent automation. We use robots in the manufacturing. But then we need people who knows how to use robots. We need quality analytics and adaptive testing. Enhanced operator. So operator is not just who can operate, but who is intelligent, and he must be careful. Plan control tower, so everything and entire thing should be planned, and the process planning is also important. Predictive maintenance and flow simulation. So these are the areas where we need to understand how smart factories transformation can take place. So the most important word now becomes manufacturing engineering technology. Not just manufacturing, but the manufacturing engineering technology, which we call it as an acronym MET. And NEMTech is advocating MET, manufacturing engineering technology, and is emerging as a leading institution aligned with this national priority. Very happy to announce that just before 3 months, we got a letter of intent to become the deemed to be university in Gujarat. We are from a distinct category where we are addressing the strategic needs of the country, like Vikasit Bharat or supporting NAP 2020. We have a unique teaching discipline. Our pedagogy is 70% hands-on and 30% theory, much similar to BAHA. And we are teaching not civil, mechanical, electrical, but subjects like smart manufacturing, semiconductor, robotics, and sustainability. Our university will be a fully sustainable example of sustainability, and our skill development pedagogy is different, and we will use that pedagogy to ensure that students get hands-on experience. So we have become a MET impact institution, and we have been working in various areas to ensure that we are a MET enabled institution. Today, we have a one-year program on, it's called IPMP, International Professional Master's Program in Smart Manufacturing, Semiconductor, Sustainability and Robotics. And we also have a unique program where diploma engineers and IT engineers sit together and they do this international professional technologies program in automation, semiconductor and robotics. So we have around 80 students who have joined in this IPTP program and around 100 students who have joined in this IPMP program. It's a one-year program, 100% residential. So our students have got bronze medal in Industry 4.0 in the World Skill Competition in France in 2024. And now we have been one of the smartest trainer in all these areas for World Skills. Now I'm going to introduce 3 star performers of NEMTech International Professional Masters Program, Ishwari, Yash, and Shruti. You must be very happy to note that all of these 3 are BAHA participants and they have taken admission here and they are the star performer at NEMTech. So I will now request Ishwari to say a few words about how BAHA has helped her and how she is doing at NEMTech. Ishwari?
Yes, sir, I'm here. Am I audible, sir?
Yes.
Yes. Thank you for this opportunity, sir. And hello, everyone. I'm Ishwari, and currently I'm enrolled in the IPMP Advanced Robotics Technology program at NAMTech. And I'm glad to share that I've been part of BAHA for past 3 years. And my journey in BAHA has shaped the way how I look at engineering and manufacturing. I believe every one of you might be relating with the fact that when you build an all-terrain vehicle from scratch, every tolerance, every decision, every design choice that you make, uh, it plays a very significant role in how the final performance of the vehicle turns out to be. And that experience makes engineering feel real and not just theoretical. And all the skills that I've acquired in Baha have accompanied me here in Namtek as well. So whenever I face a challenge here in the robotics labs of Namtek or while dealing with some projects, I always have this resilience that I've gained from Baha, which accompanies me and ensures that I'll find a way out. So if I say that Baha has taught me how to build, Namtek is one who is ensuring that I build better, and not just better, but how it suits all the other domains like sustainability and how it impacts the other domains of the society as well. Engineering and problem solving mindset that I've acquired from Baha has always accompanied me here at Namtech, and I believe that it will certainly accompany each one of us in every domain of our lives. Thank you so much for this opportunity, sir.
Thank you, Ishwari. I'll now request Yash Modi to say a few words.
Uh, Hello everyone, good evening. Myself Yash Modi, and I have been enrolled into the Smart Manufacturing course here at NAMTech. part of the IPMP program available here. And over the past few years, my journey through BAJA SAEINDIA and NAMTech has shaped me in ways that go far beyond academics. BAJA was my first real exposure to engineering outside the classroom. When you spend hours in the workshop trying to make a design work, or when something fails just before testing, you realize that engineering is not just formulas, it is about patience, teamwork, and I'm pretty sure everyone here has felt it about the problem solving under pressure. Those moments, whether it was fixing a part late at night or coordinating with the teammates during the crunch time, taught me how to stay calm, communicate better, and take up responsibilities. The next milestone was of me becoming a part of the Baha Alumni Committee as well. It allowed me to stay connected with the community and contribute in whatever way possible to the next generations. And it reminded me that learning never stops and that sharing knowledge is as important as gaining it. And now, my time at Namtech, it has added a very different kind of learning to my journey. Namtech here focuses a lot on practical understanding and not just how things works, but actually doing them. Whether it was working in the yo-yo lab or the CPS labs, or learning how the different modern manufacturing systems operate at the MSL plant visit that we had, and understanding how the digital tools support the real factories. Namtech has helped me in seeing engineering from a much closer and a realistic angle. The environment here encourages you to ask questions, try different things, make mistakes, and learn from them. It has made me understand that being an engineer is not about having the answers, but about willing to explore the different approaches out there. So I would say together these experiences, the Baha'is India, the Alumni Committee, and NAMTech have played a very big role in shaping who I am today, and they've taught me resilience, teamwork, curiosity, and responsibility. I would say that I didn't become perfect through these experiences, but I became more aware of my strengths, my gaps, and the kind of engineer I would want to grow into. And for me, that clarity itself is a very biggest takeaway. So thank you so much for this opportunity, sir. Thank you.
Thank you, thank you, thank you. And then finally, I'll request Shruti Godke. Ishwari and Shruti both are from KKWA College of Engineering, Nasik. Shruti?
Yes, sir. Am I audible, sir?
Yes, yes.
Mm. Hello, all. I'm Shruti, and I'm a proud Baha alumni. And currently, I'm studying at School of Robotics at Namtech. Um, I'm sure that most of you will relate when I say that when you are working in a Baha team, then you are always you have to work through the across the subsystems. Let's say if you are in a steering subsystem, you have to discuss with the suspension subsystem, the powertrain, and the chassis subsystem. So Baha trains us to have that collaborative mindset to work across disciplines. That same mindset that I have developed being a part of Baha for 3 years of my BTech is now helping a lot uh, me at Namtech, because it's been 2.5 months only that I have joined Namtech. And in the School of Robotics, we are doing a lot of diverse projects in the field of soft robotics, in the field of serial manipulation. So all these projects are quite diverse and the teams are very dynamic. So the whatever interpersonal skills I have learned through Baha experience is now shaping my career in robotics at the prestigious Institute of Namtech. Also at Baha, we used to be the part of presentations at the event on the big stages where the industry leaders were our judges. So that interaction with those judges is also helpful here, because here the faculties, most of the faculties are from IITs, from big colleges, and also international faculties. So these working with these international faculties and professionals is also a tough job. So that also is a part that we have to deliver at Namtech. So I am just a proud member of BAHA team. That I am proud that in my second year I joined BAHA, and now that one decision is now helping me shape my career in my field of robotics. Thank you.
Thank you, Shruti. So these are just three examples. There are many more, but I would not take your time and would continue with the presentation. So once we have got the letter of intent to become the university, from August 2026, we are starting 6 master's program: Master in Smart Manufacturing Technology and Management, Master in Semiconductor Manufacturing and Management, Master in Sustainable Engineering and Management, Master in Robotic Engineering and Management, Master in Automotive Technology and Management, and Master in Data Analytics and AI. These are the 6 master's program, and you will see the word management everywhere. So we are going to create techno managers in this 2-year program. And maybe a year after that, in 2027, we will also start the undergraduate programs. So I'm now going to show you just a 1-minute video of how we give hands-on experience to our students at Nemtech. We are taking a test. So they are near the engine, they are near the car, and the entire exploded view of the car is AR/VR simulated. Okay, so with this, we start our presentation on Manufacturing Excellence Award. What you are interested to see, that how can you get maximum points in this? Yeah, that's fine. Hello? There you go. Just 1 second. Okay, so we will continue on the Manufacturing Excellence Award. So this award was constituted this year for 2026 by Nemtech for BAHA India, whether it is H BAHA, M BAHA, E BAHA, or A BAHA. It holds good for all the events. And the objective is that we must be able to recognize and reward a team that demonstrate manufacturing engineering technology across full product realization cycle, from design intent to validated product delivery, using real world processes, quality tools, and documentation standards. Yes, we understand that first year you may not be able to show for everything, but at least one component which you have made, maybe you have used 3D printing, or whether you use CNC machine, all this will play a very, very important role into this. The key goals of this award is to simulate industrial manufacturing, to instill quality and documentation culture, to bridge industry academia execution gap, and to promote continuous process thinking. So we want you to inculcate this knowledge of how to do manufacturing, not just manufacturing, but smart manufacturing. So in this award, it is expected that the team would understand what is design for manufacturing, what are the various fixtures and tooling. For example, when you make a roll cage, uh, how do you ensure you use various cardboard fixture to find out the distance and all those things. So that is also type of fixture. Uh, you must be able to do a process planning. Whatever you are manufacturing, you must be able to write down before you start manufacturing. You must be able to check the quality and ensure that whether the intended product as per the quality has been made or not. And also you must be able to optimize the cost and the productivity. So you have to use industrially accepted processes, what industry use. I'll be talking about that. And then you must have a capability to showcase traceability, standardization, and workflow discipline. So there are many standards which you will have to use. For example, when I was in my engineering college, I used to use PSG design data handbook, right? So there were all limits and fits and everything was given there, and we used to adopt them. So, and finally, you will have to give a presentation as a professionally structured manufacturing approach rather than just a fabrication. So we are now talking about understanding process. And before going to any process, you must first understand the design. So you have to make a concept, you have to design those parts and design for manufacture and then manufacture those parts, check that the quality is intended, and you are able to use a connected workforce, that means more industry 4.0 into this. You must be able to integrate process FMEA. So whatever you were doing earlier in design FMEA and process FMEA, we are splitting them. In design report, you will talk about design FMEA, and in manufacturing excellence, you will talk about process FMEA. So we are delinking them. So you need not present process FMEA in design. You can show your process FMEA in manufacturing. And similar to your design presentation, which you will come with various posters and charts, same thing will happen here. You will come with various posters and chart. So you must be able to apply cost, quality, productivity, optimization principle during part or subsystem. So it can be one part, one system, or the entire vehicle. So demonstrate traceability and standardization at every stage in the production. This is what is the objective of this award, and we hope that you all try to work towards that, similar to what industry is doing. For example, design FMEA, what you have been doing is similar to what industry has been doing it. Similarly, process FMEA is something which what industry is doing. You also have to assume that you are going to produce 4,000 units per year, say like a sales presentation, and your production duration is of 5 years. And based on that, you have to. So here again, we are delinking sales with manufacturing. So up till now, some of the manufacturing aspects was presented during sales presentation. Now those manufacturing aspects will be presented during manufacturing presentation. So what is the manufacturing process you're going to use? What type of process sheets, what type of factory layout you will have, how are you going to do the material handling, all those things you will be able to explain to the judges, and then also make proper documents like process FMEA, process flow chart, control plan, standard operating procedure, work instruction, and so on, right? So the emphasis is on transitioning from a prototype level build to a mass production. So you don't have to do the mass production. You have to assume that you are going to do mass production, and accordingly you have to. So there are two aspects. One is you make some component in a smart manufacturing way, and you also plan the mass manufacturing. You don't have to do the mass manufacturing, but you have to plan and demonstrate the mass manufacturing ready process. Okay. So there are certain rules here, and that has been shared with all of you, that it is compulsory for all the team. It is not an option, and each team must submit a manufacturing excellence report. So like you submit a design report, there will be a manufacturing excellence report, and the report must follow the official naming convention similar to design report. There will be a deadline which you will be declaring tomorrow, next week, and based on that, you will have to submit your report and prepare a presentation in the form of a poster. So in your report, you will in the first page you will talk about the team name, team number, college name, and the captain email ID and contact number in case we want to talk to you. And also in your report, you will ensure that there is a design intent, there is a process planning, tooling, sticks and fixtures, inspection system, process FMEA, cost analysis. All this is added in your manufacturing excellence report, right? And you please don't copy them. We are going to use plagiarism software to ensure that you are not copying it from somebody's report, right? And the team also should come with a hard copy, because we will not be allowing you to show it from the laptop or give a presentation. In the daytime, it will be very difficult for the judges to stare at the laptop. So it's a very nice way to get a hard copy or to make posters there for the judges to see. So the report will be a 2-column format similar to what you did for your design report. You can have a 10-page and you can have 5 extra page showing figures, tables, sketches, photographs, whatever you want. And if you're an all-wheel drive or 4-wheel drive team, then you can have 5 additional pages. So then it becomes 10 plus 5 or 15 plus 5. And then you must be able to use dimension, which are using a metric unit. And every table, figure, graph has to be clearly labeled. And in case it has been copied from some reference, the reference also must be mentioned near the table or the figure. So these are the various aspects which will be added in your report, whether it is design for manufacture, manufacturing process, tooling, jigs, fixtures, various evidences. And then I'm going to talk subsequently about what is PPAP and other things in the subsequent slide. So from points point of view, if we are going to give you 100 marks out of this, which will get converted into 50 marks later on, then these 100 marks are divided into 8 areas. And this 8 areas is if you are able to demonstrate design for manufacturing, where you show a CAD diagram, a CAD drawing, a 2D, 3D drawing, GD&T, geometrical dimensioning and tolerances, tolerance stack-up analysis, strength to weight ratio, manufacturability justification, material selection logic, all these things, if you are able to show through design for manufacturing, DFM, then you get 15 points. Similarly, if you are able to show process planning and routing sheet, where you talk about various sequence of the operations and so on, then you get 10 points. If you are able to demonstrate that you use tooling, jigs and fixtures, whatever way they are or how simple they are, you get 10 points. And if you are able to show that, yes, you have used CNC machine or you have used 3D printing and maybe some evidence through photographs or videos or log sheets or inspection checkpoints, then that will also help us to you getting 15 marks there. And then if you are able to show quality control, you got it tested at AR. So for example, you made a battery and got it tested at ARI or any test agency, or you made a component and you got it tested on a CMM or a profilometer, or you have checked the dimensions and noted that they are within the tolerance, then you have 15 marks there. If you are using any advanced manufacturing and lean implementation, like you're using a CNC machine to manufacture certain parts, or you are using lean tools like 5S and all those areas, Japanese modes of working, and you are able to demonstrate that, or you are able to integrate smart quality and productivity tracking methods and demonstrate tangible improvement in terms of accuracy, repeatability, cycle time. So you will say my cycle time has reduced, I'm getting repeatable results and more accurate product, then you get 15 marks. And then documentation and control system, that means if you're able to show process FMEA, control plan, SOP, work instruction, all those things, then 10 marks. And if you are able to do any cost optimization, process efficiency, you do a C analysis and make the parts thinner with more embossing, or you are able to do a make or buy decision, or you are able to recycle some material, right? Or you are able to estimate the cost. If you make one piece, what is the cost? And if you make 4,000 pieces per year, what is the cost? All this will also fetch you 10 marks. So that's how you will be able to get this 100 marks very easily if you understood this 2 slides. So presentation would be similar to what you did in design. Maximum 5 team members would be allowed. You have to make a poster, uh, get the hard copy of the report, and then you have total 30 minutes, 5 minutes for setup and introduction, 15 minutes for speaking the presentation to various judges, and then judges will take another 10 minutes to ask you questions and give you the feedback. So as I told you, maximum of 5 team members. So 5 team members can go for manufacturing, 5 team members can go for design, and so on, right? And this presentation must be supported by poster, technical data, photographs, documentation, and so on. So the spirit of Manufacturing Excellence Award is that you must be able to excel in manufacturing and prove that you are an industry ready professional where you have thought beyond design in terms of process, precision, and perfection, right? So this we hope will inspire you to build not just component, but a culture of quality and continuous improvement. And this also reinforces the manufacturing excellence as a key capability for future engineers. So if you are a design engineer, fine. But if you are able to do design and also manufacture, that would be great, right? I will now request Ujjwal Modi, my colleague, to continue with the presentation. Ujjwal?
Thank you, sir. Am I audible?
Yes, you are audible. You are audible.
Yeah, thank you. So, in with continuation with Vora sir also, and probably you have seen also in the previous slide. So, one of the aspect is in the manufacturing cycle. Like so, whatever you design, whatever with help of the CAD modeling or whatever you did with the design for manufacturing, design for assembly, you need to show in the presentation, in your report, like manufacturing execution. So if you see in the cycle, it comes from all the design from prototype to production to test to quality assurance, logistics, support, and the development. So your product or whatever you made your product by yourself, it has to have the complete set key points of from starting from design to the development side. Next slide, please.
Yeah.
Yeah, same with the so this for the different manufacturing process. For example, we have used the casting or probably we have used the forging, building, additive manufacturing, CNC machine, as sir said about automation, forming. So every different aspects of manufacturing process that you have explored or that you have used during the making of your ATV, it should be reported, it should be have the proper evidence that you have did by yourself with the respective process, with the respective methodology, with the process parameter, with whatever manufacturing process we have used. So here are the few examples that you can or probably we have considered also in the one of the process that is mentioned here. Next slide, please, sir. Yeah. So what could be the manufacturing workflow and work instruction? So sir also mentioned about the Japanese mode of the work culture, having the 5 years and Kaizen and all those things. So as you need to prepare yourself for the industry ready professionals, you also have understand about the manufacturing workflow that need to be start with the preparation. I'm sure that you have whenever you start with your any kind of manufacturing or machining, you have made your preparation well or very well and not have any last moment delay with the manufacturing setup. So that need to be uplift yourself with the manufacturing excellence if you have prepared well from the starting from sketch to concept to CAD to the manufacturing, and also if you went to the any kind of inspection or with some sort of CMM or any other method. So you must have to check quality check, and also you must have to document all those things with the proper documentation, and as in when required you must show in the presentation as well as in your report to get maximum marks in the respective category of the manufacturing excellence award. Next slide, please. So now designing the design for manufacturing, I'm sure that whenever you use your whenever you try to make your ATV or machining with help of machining, you have used the design for manufacturing with each and every component. There are in the guidelines that you may use or you may get your part from outside or from third party as well. But whatever component that you have made yourself, it should be based on the design for manufacturing. It should be work at the extreme condition in the during the path in the competition, as well as with the proper tolerance being used in your car. Like for example, if you are using the modular design, then chassis, then suspension, drivetrain, electrical module, like so everything need to be based on the guideline for the design for manufacturing, and that has to be reflected in your PPT and the report somehow, which from based on that we can evaluate, or the whoever judges are there to evaluate your manufacturing excellence award can able to judge based on your documentation. Next slide, please, sir. Yeah. So this is again the same concept for manufacturing process and the inspection. The way I've showed before with the graphical way, here it's more into the flow chart that what can be done with the starting from the design team to release the design, then manufacturing. Your bill of material comes into the picture. You're making or buying the parts, then you manufacture with the process flow meter, then CTQ, safety critical parameters. Then it comes with the inspection and the report presentations, then the gauging requirement, assembly, and the vehicle. And as in when required, you must have the supplier selection criteria for the critical part. Like so, this is it's on you to decide like which need to be optimized and what to put and how you make the more in each and every aspect to get the maximum marks in the respective category. Next slide, please, sir. In this fixture tool design and the tool accuracy, we also encourage you to put some sort of evidence for the fixture and the tool design as well, because somehow we don't want you to use any non-industrial practice to manufacture any component that are not able to justify your product manufacturing life cycle, which cannot be accepted by the industry. So whatever you make the component with any kind of manufacturing process, whether it is additive manufacturing, CNC, machining, casting, forming, anything. But if there is a requirement of fixture, tool design, and the tooling accuracy, that has to be purpose, that has to be justice for why you are going with this design, why the team need to be have the fixture, and if that is required, then you need to put that evidence and you need to put the design of that fixture and how you made that design also need to be reflected in your presentation or somehow in the report. That has to be properly documented, and the justification need to be provided in your report and in your presentation. Somehow some example I'm telling you or I'm explaining you that you can put in a way of 2D or 3D drawing with the actual production drawing with and with the GD&T, as well as the bill of material, bill of tool that you can use. Then material selection you can put it in a way. Then the trial and fit inspection that you can put, alignment verification if you have done with your tool, or if you have done with your fixture, that you can put it in the report, or you can put it in your presentation. Then next slide, please, sir. Yeah, so that's it about from my side. I'll now request back, hand over to Dr. Vora for further.
Sure.
Thank you, sir.
Thank you, Ujjwal. And we will continue. For example, we talked about material handling system, and so what we are doing is we are showing you one slides on each of them, which is not there in your guidelines. So we would like here we are giving you some more information, so you may get some idea that how can you demonstrate this. For example, you have to make a process sheet. Then how will you create this process sheet for 400 pieces, right? What will be the sequence like? For example, you make a roll cage. So first you do the marking, then you do the bending, then you do the welding. So that flow chart you can make that what will be the various processes which will be used, and then you also do the Jigsaw fixtures, there you also do the inspection at every stage. You also ask the driver to sit in between and check. So all this becomes a part of the flow chart or a process sheet. And this sheet will serve as a primary instruction set. So today you are doing this for one product, one prototype. But tomorrow, if a technician is doing this or a mechanic is doing this in a factory and he's going to produce 400 pieces, this flow chart or this process sheet will be used by him कि सर ने ऐसा ऐसे लिखा है तो मुझे ऐसे ऐसे करना है, right? So that is what you are going to set. Integrated material handling, how materials will come in, how materials will be transferred, how the final product will go out. And then you must be able to do the resource allocation. इसके लिए कौन सा material लगेगा, कौन सा machine लगेगा, what is the machine time, what is the weight and type of the material, how many people are required. So whether it is like man, machine, money, everything has to be added in resource allocation. And then how did you implement this? How did you finally get the final product? What are the set of documents you are going to have? All those things also you will have to add, right? You can just, as I told you, we can do a raw tube. We buy those tubes, we cut them. We can use CNC machines where we can do deburring, inspection, and then assembly of parts. So it can be any way. For example, you are going to make a casting. Tomorrow for an engine, you are going to make a piston. Then piston needs to be casted. It's casted in a series. Like 20 pistons are casted together through gates, and then they are cut, and then they are sent to the machine shop. Then they are machined, and then a process happens to improve its surface finish, and it's not circular, it's oval in shape, different dimensions at the top, different dimensions at the bottom. So piston is very critical. So how are you finishing that? So, and then how are you going to visually check that? How are you going to use various equipments to check its ovality and taper and all those things? So this is also very important, that you must be able to make a process sheet. So how will a process sheet look like? So here I'm just showing you how a process sheet looks like. Like for example, you have made a suspension arm of, so a clear identification of the component, that you are making the suspension arm bracket of the suspension system of BAHA. And you must also learn to give part number to each of this. So your entire BAHA may have so many parts and you may get mixed up. Even the hardwares may get mixed up, where you somewhere you want M8, somewhere you want M10, somewhere you want M12 of a different quality, and the pitch may be different. So you will have to give part number to each and every component. Suppose you are using the same hardware at two places, then also the part number can be same for both the hardware. But you must have a practice of giving a part number to each and every component. So then maybe you can even punch the part number on it, just to understand how in the end a visit to industry will really help you, right? So maybe you decide that you will make 10 pieces per day, or 10 pieces per week. So that is how you are going to do. When was this process made? What date? And is there any revision in this? What is the material used? What is the lead time? Who has prepared this process sheet? Everything must be entered into this. And then you can see the structure. First, the material preparation, cutting them, drilling, bending, deburring, welding, quality check, finish or paint preparation, all these things. So this is the process sheet which you have to write. What machine will be used, what tools and jigsaw fixture would be used, what dimensions would be checked. All this is mentioned here with time. So machine layout and control plan. So for example, you are going to manufacture a roll cage, then how will your workshop look like? Where will you keep your bending machine? Where will you keep your welding machine? Where will you do deburring? Where will you do painting? All that thing you can do. You can make a layout. So indirectly, today you are making a layout for your workshop. Tomorrow you may make a layout for a big factory. So today, for example, if you go to Chakan in Mahindra and Mahindra, they are building up the electric vehicle. There are two types of electric vehicle in a fully automated factory. I had a privilege to see that factory, and very few people, everything is robo. You may say that then log kya karenge? The people will be losing job. No, you require a lot of people there who can repair and maintain a robo, or who can control the robo. right? So we will require a lot of people, but with a different skill. So this everyone has to reskill themselves in this area. So all these are very, very important. We need to do risk mitigation. We need to do standardization. So all this also needs to be done. For example, you need to do pokai. Okay, your hand must not come below a press. So you have to be safe. So what two things have to be done together so that the press will work, not by just one thing, because there could be a mistake and somebody may press a button and there could be an accident. But to avoid that mistake, we can have two or three things to be done together. Only then the machine will work. Then there'll be more safety aspects. So how do you do this entire layout is important. And then, so this is one example of a machine layout. It shows incoming material, then machining station 1, quality check 1, machining station 2, assembly station 1, quality check 2, and then the finished component. So you can see how you can give an icon, nomenclature, and then you can show the layout. Now this layout can be a straight line layout or a U-shaped layout or a square shaped layout or a C-shaped layout. You can decide depending on the space available and also demonstrate that. Then the control plan structure. So you need to write the operation number for each of them. If it is drilling, then what hole you are going to drill, what is the diameter of the hole, what type of drill will be used, what will be the speed and feed rate of that drill, what machine you will be using, and whether how will you check, how will you do a process FMEA, assuming that the hole may be too large or oversized, or it may be too less, it may not fit. So for that, you need to have control measure like go, no go gauge or a vernier caliper or a micrometer and all those things, right? So whether it is drilling, bending, welding, final check, for everything you must understand what is the product characteristic, what is the process characteristics, what is the process FMEA, and what are the inspection methods, and so on. Then we also have to understand how various standard operating procedures are made. SOP means standard operating procedure. So you need to make all those operations. Suppose you want to use a press, then you have to write down 10 steps of using that press. Press this button, switch on the main switch, ensure that there is somebody cannot get into that, and so on. So you will have to write down or type it down the standard operating procedure, take a print and paste it near the equipment, right? So that everyone reads that. And if you feel that the workers are not able to read in English and if they need Marathi, then you can translate and put it in Marathi also. So put one in English, one in Hindi, one in Marathi, local language, the way you want, right? And then you must be able to validate this framework. You must be able to ensure that there are data-driven decisions using AI. And then how are you able to trace this? How are you going to make reports of this? All these are also very important. So standard operating procedures in process validation plays a very, very important role in data-driven validation. And we need to use various documents like PPAP. I'm going to talk about PPAP in the subsequent slide. PPAP is production part approval process. And this is a very standard design method. What we call it as new product development. So there you need do a pilot run, you measure, you analyze and find out CPK values, and then adjust the process so that you have minimum rejection, and then approve the entire thing, and then allow people to use it, right? So for example, if you want to make a standard operating procedure for welding fixture setup, then how are you going to do it? What is the visual aid? What description you are going to write? What is the impact of error and so on, and how you are going to use those scrappage and so on, right? So here is another data-driven SOP flow chart. So for for example, what is the process parameter? What are the standards operations? What are the production run? How do you do data acquisition analysis? How do you do process validation and further improvement, right? So I talked to you about NPD, new product development. So in USA, long back, there were three big companies, automotive companies. One was Ford, one was General Motors, and one was Chrysler. And all three were centered around Detroit. and they were using their own design, own style of manufacturing, own process control plan. And then one fine day, they all three met together, the seniors, and they decided, why don't we come out with a process? Because there were always cross flows where an employee of this company will join that company and so on. Uh, for example, today in Pune, we have Eaton Technology, we have John Deere, we have Cummins, and the employees of those companies keep on playing a musical chair by changing jobs in this organization, because all three organizations are a multinational company and they have their own common style of working. So similarly, these three also decided to work together and they came out with a very structured new product development known as NPD. And I had a privilege in Mahindra to learn the Ford way of NPD. So later on, this Chris Chrysler was taken over by Stellantis. So it's called Ford, GM, and Stellantis now. And whatever documents they produce and whatever the structured way of NPD they explained and documented it in a form of a booklet is used even today, right? So just an example of NPD, we are halfway through. For every design and production, there is a concept phase, there is a definition phase, there is a design phase, and there is a production phase. So in the concept phase, you do a feasibility study, you find out the voice of customer, you call it as QFD, quality function deployment. You try to understand what do the customer want. So for example, if you are going to produce a two-wheeler, then what type of two-wheeler needs to be produced? Whether that two-wheeler has to be similar to like Ola, or it has to be similar to like what Ether is producing, or similar to what other companies are producing. How will your two-wheeler be different than those? What do the customer really want? What do the girls want? What do the senior citizen want? What do the ladies, senior ladies want? All those things you will have to talk to your prospective customers, and then based on that, make a concept. Once you make a concept, that has to be approved not only by the design head, it also has to be approved by sales and marketing head, because finally he is the one who will say yes, ye chalega bazaar mein aur ye bikega. So you will have to take the approval from so many people before you start your design. And then you need to define that what will be the method of manufacturing, what type of material you're going to use, whether you're going to make it or whether you're going to buy it. And then you have to make a system design specifications, and who will make this if it is to be purchased, who is the vendor, can I decide the vendor now even before I start the design, so that I can involve the vendor also in my design FMEA in the design. Then comes the design phase where you do an overall design and check whether those parts are matching with each other or not, limits, fits, and everything. And then get into the detailed design, the dimensions of each and every dimension of that component needs to be decided, the tolerances need to be decided. And then based on that, you make a couple of prototypes and then test those prototypes, check whether everything is assembled properly or not, and do some qualification testing. Then comes the production phase where you have made some 5 prototypes, everything is running well. Maybe you have sent one vehicle to ARI or ICAT for certification, and now the certification is also done, the type approval is also done, and it's time for do mass production. So for mass production, you will have to understand what is the production design, process design, what are the jigs, tools, equipment, and fixtures used. Then do a pilot production of say 100 pieces and find out you do the evaluation, what went wrong, what went right, and then do the full production startup once you are sure that this 100 and this 100 vehicle which you make, you can give it to some journalist, you can give it to some your senior employees, so that they run this vehicle and give you a real feedback, and accordingly you can make all those modifications even at the beginning of the production stage. Once your production starts, once your tools are ready, then it will be very difficult to change those tools, because these tools are very costly, and once you make it, it will be very difficult to change. So this is an iteration process of production where you get confident, yes, now everything is right and we are moving in the right direction and our product will sell. Accordingly, you will work on this. Okay. Am I audible? Hello? Hello,
Yes, sir,
Ujjwal?
you are audible.
Yes,
Okay.
Yes,
yes,
sir, you
sir.
are audible,
Yes,
sir.
sir. You're audible.
Okay. So this new product development has various stages of design. Like for example, DR 1, 2, 3, 4, 5 stands for design review. You do a concept, and get it reviewed. A group of people sit together and do a review. This group of people may be from different departments like production, quality control, sales, marketing, design. But basically, the designer has to defend his design, and maybe the production guy will say that, do you think that this design can be produced? Is it designed for manufacture, right? So that is all what you do in design review at every stage. Make a concept, do a design review, make a detailed design, do a review, make a prototype, do a review, then do some testing, and then based on the testing, what parts have failed, what parts have not failed, and what correction needs to be done in the drawing and the product. Again, and then you do the initial pilot production of 100 pieces, and then you do mass production of 4,000 pieces. So this is how the step by step. So these are gateways which every design engineer has to pass and then move forward. So you need to do the production preparation parallelly, you need to decide the supplier or the vendor parallel, and so on. So it is not just design, it is not just manufacturing, it is business. So the business case has to be made, which is done through the marketing department. Then the design has to be done by the designer, and then the manufacturing team must join in to ensure that how is the production done. So in design, we do a design risk assessment, we do design FMEA, we do design review. In business, we do a business case, and then we present this business case with project plan and take the approval of the business case from the managing director and then work on that, right? So business, that is marketing and decision making, design, that is design, concept, product, design FMEA, and all those things, and making drawings, 2D and 3D drawings, and doing an analysis. And then finally process, that means the manufacturing process, or the manufacturing process definition, and then process FMEA, process control plan, and this PPAP and IPPAP, which I will be explaining you in the subsequent slides. So before I talk about PPAP, I want you to talk about APQP. So first step is new product development. And under new product development, you do APQP, that is Advanced Product Quality Planning. So this is basically for the vendors who are supplying the parts to you. So suppose you have designed a transmission and you have designed certain gears, and you have given this gear to somebody to be manufactured. You have very religiously made a drawing for this, that what will be the pitch and what will be all the dimension of the gear, and then you give it to someone who can make a gear for you because you don't have a gear hobbing facility, and then proper heat treatment, he will also guide you. And if you do this, then that is called a good way of advanced product quality planning. So APQP stands for Advanced Product Quality Planning. And if you are giving this to somebody to make it, then you have a role to also go to their factory and check the APQP. So under APQP, there are various aspects. One is called PPAP, that is production part approval process. Second is FMEA, whether it is design FMEA or process FMEA. Third is measurement system analysis. You need to put this under CMM and do a measurement and find out whatever tolerances you had decided whether it is met or not. And the statistical process control. So PPAP, FMEA, MSA, SPC, design review, and all concepts, design, everything is a part of the APQP. PPAP is generally done for a vendor who is going to supply to you. So if, for example, as I gave you an example of a gear. So APQP is defined in 5 steps, and the core tool is IATF 16949. And under this standard of 16949, they talk about NPD and APQP. So you need to plan and define, you need to do the product design and development, process design and development, product and process validation, and feedback assessment and corrective action. So PPAP, as I told you, is a production part approval process, which is used in automotive industry, now in many other industry also. It's a standardized procedure where suppliers provide documented evidence to customers. So if I am a customer like Mahindra, Tata, or Maruti, and there are OEMs who are making tires, suspension, steering, brake, catalytic converter, exhaust system, all those radiators, then as a manufacturer, I will go to their factory and check everything. And I will ask them to make a PPAP document, that is production part approval document. There are some 14 to 18 steps, which I'll show you in my subsequent slide. So epic UP becomes very critical and involves detailed check. As I told you, there are 18 elements to confirm process capability and understanding of customer need. So these are the 18 steps. PPAP production part approval process, like you make a design record, you do an authorized engineering change document if you change anything in the drawing, engineering approval, design FMEA, process flow diagram, process FMEA, control plan, measurement and system analysis. You read all these things, but all this now needs to be done in 18 steps, right? So once these 18 steps are done, then we need to make various warrants like part submission warrant, appearance report, and so on. And this will also help the 5 stages of PPAP. Quickly talk about the manufacturing process plan. You will see a robo which is making a car. So actually the car which unpainted car body which they make is called BIW, body in white. So this is a picture of a robo being used for manufacture of body in white. So you take a floor, then you put the side panel, you put the roof, and then you weld those joints and so on. So this is for this you have to make a plan how each and every step will take place. So what is a manufacturing process plan? It's a systematic approach to organize and optimize the required sequence of operation to transform the raw material into finished product. So in this, as a manufacturing engineer, you have to develop a comprehensive plan that will address target cost and lead time, production volume and requirement, equipment availability, material specification, production routing, and quality assurance measures. So in today's digital manufacturing environment, a manufacturing process plan uses advanced technology like computerized process simulation, artificial intelligence, machine learning, and 3D modeling to validate and optimize the processes. So how does the manufacturing process planning work? You need to coordinate the necessary resources in terms of man, machine, money. You need to do a process mapping and documentation. You need to do the scheduling and timeline development, and you need to do implementation and control. So all these are very important part of the planning. And here you can see that automotive company manufacturing flow process. So you make a body in white, you get the electronic part, you get the plastic part, you get the glass part from outside. You assemble them in your body in white, and then you put the seat covers, tires, everything. And then you make the entire vehicle assembly. So there could be a sub-assembly of engine component like piston assembly and so on, or you can make a sub-assembly of engine assembly itself, or the body in white. So you can see how the mass manufacturing is done of a passenger vehicle here, how many robots are being used, how the conveyor takes the body forward, and different robots will do the different types of job on the same vehicle and repetitively on the other vehicle also. So quickly now I'll talk about process FMEA in the next 10 minutes, and then my colleague Sankata Tiwari will talk. So FMEA stands for failure mode effect analysis. So before the part fail, we must know that what are the various areas through which it will fail and what corrective action can be taken. So FMEA is based on inputs and output. So one can do brainstorming, one can do capture the voice of customer, one can do process mapping, process history, all these things you bring on the table and do an FMEA, process FMEA. And then what we get is the list of actions to ensure that the defects are minimum, history of the actions taken, and so on. So FMEA, when we talked about concept, we talked about design. So when you start the design, it is design FMEA. When you complete the design and start the production, it is process FMEA, and so on, right? So here you can see the roadmap. You prepare yourself with all those and then settle down and then perform a process FMEA. And then once the process FMEA is done and then recommended actions are taken and the risk priority number has come down, then you work on design validation plan and report, process control plan, and so on. So DVPR is design validation plan and report, and design FMEA is failure mode and effective, whether it is DFMEA or PFMEA. Okay, so here you are talking about process FMEA. How do you go about? You do a small production run. You first do one prototype, then more, and then you talk about the mass production. Okay, So here you can see how process FMEA can help to analyze the product and find out the risk. So process FMEA form is almost similar to a design FMEA form, but not exactly the same. The first few columns are different. For example, what is the process step or function? What is the requirements? What are the potential failure mode? What are the potential effect of failure? And so on, right? So this is how a process FMEA is made. So documents, item, model, year, vehicle, everything has to be mentioned here. And the key date is initial due date. This cannot exceed scheduled production design release date. So we need to work fast. So this is how the total process FMEA form looks like. And one can expand this further. Okay. So there is a process functional requirement, then there is a process potential failure mode. We need to work on both. So this is how a process FMEA form will look like. It is process step function or a requirement or a failure or a potential failure mode. We need to work on this and also check what is the potential effect of this failure. So these are the process functions, the examples of process functions. And these are the identifying failure mode and so on. So how the failure mode is affecting and how the failure mode, what are the potential effects of failure and what are those critical items where dimensions plays a very important role and you can play that role. And then in design FMEA, you have to decide, here you will see severity, occurrence, and detection. These are the three numbers. When multiplied, they become the risk priority number. So here you can see how severity is defined. If it is very, very risky, then it is 10. For example, it is not meeting the government regulation like meeting emission norms and safety norms, then it is 10. But with time, this number would come down. Then if it gives a warning, then it is 9. If it doesn't give a warning, then it is 10. And then whether a particular component, whether there is any loss of primary function, then you reduce something. Whether the vehicle is inoperable, or all those things. And then whether it loses the comfort of the passenger or the convenience of the passenger, and whether there are any fit and finish problem or whether there are any squeaks and rattle, or there are minor fit and finish. And so on, right? So this is how the severity is decided. Similarly, occurrence is decided how many times the same component is failing again and again. And then we have a detection that how do you detect that it's a fail-safe mechanism or it's a very good design control and so on. So if the design control is good, it is 10. If the design control is bad, then it is 1 or 2. So you need to find out severity, you need to find out occurrence, you need to find out detection. And then multiply them together. So if it is severity out of 10, occurrence out of 10, and detection out of 10, then we multiply them together and what we get is the risk priority number. So risk priority number is the product of the severity, occurrence, and detection scores. So now I'll request the last 10 slides. I will request my colleague Sankata Tiwari to come forward and give his presentation. And then we will have a question answer session. So Sankata Tiwari, are you there?
Yes, sir. Yes, sir. I am here.
Please take it.
So hello everyone. So already Dr. Vora sir has almost covered every aspect, but in addition to that, I'll like to add few points. So like scalability point. So like Baha teams are right now they are manufacturing their vehicles in a prototype manner. But in this manufacturing excellence award, what is expected that we are expecting them to demonstrate that whether this design or this prototype is ready to scale up or not, or ready to scale up for a mass production or not. So we need a like a plan for that. So you can see these are key factors for when we talk about scalability of a business model. So already Vora sir has mentioned some of the points. So how you can create you're supposed to create a business model plan in which you should have a customer focus. You should have a like a what are the marketing strategies, what are the sales so all those things, customer relations, after sales, everything you have to like incorporate in that, then and in a different manner, like in a pre-seed manner, and when you are seeding your business at another level, and how you are scaling up the business at a very large model. So in that aspect, we are actually needing the information from you to understand the manufacturing excellence in terms of scalability. So next slide. So very important part is cost and quality and productivity optimization principles. So while manufacturing your vehicle, whenever we are producing or we are creating a product and a business model based on that product. So we are definitely worried on the cost factor. So based on that cost factor, we need to decide that yes, whatever manufacturing processes we have choose, those are cost effective, those are low cost manufacturing product, but at the same time the quality is not compromised, and the product whatever we are manufacturing, the manufacturing processes are showing its repeatability and their reliability to produce the component. Like if we produce 1,000 component, those 1,000 components should have uh, give us the same kind of result, the same kind of performance. So these things need to be checked and validated, and it must you must also show this on your in your slides and during your change like choosing your manufacturing processes, like how you are choosing those processes based on which you are complying these factors. So like in cost optimization technique, this design simplification should be there so that the cost optimization could be there. The standardization process should be there. So uh, of course in automotive it's very important to use the standardization, like we any kind of nuts, any kind of springs, whatever we are using, it should be of standard sizes. Like suppose at any point of time the vehicle got failure or any kind of mishap occurs, then we can like repair it at any point, at any place. And it is not like this is some different brand car, so we cannot repair it at this place or that place. So that kind of standardization is needed. So the product all you have used, like nuts, steering, all those in the chassis or in the roll case, everything what you are using need to be standardized, and you are supposed to show that yeah, these products are standardized, and these can be used at various places. And if you are procuring those items, then you can show that what standards you are using, what standards you have followed. Similarly, the manufacturing process and trade-off, like which process is costly and which process gives better result. So we have to select a trade-off in between the process, like outcome and the cost. So that kind of things. Also, the waste reduction. So the lean principles must be used in the manufacturing processes, whatever you have used. So which actually ensures like whatever waste you have generated, or you have tried to reduce the waste, whatever what may have generated in the during the manufacturing processes. Next slide, sir. So these under these five pillars we can see, like first of all inspection, whatever things are there, you should be measure them, all you should use the different gauges, standard measurement principles. The welding what you have done, you should have checked that whether these weldings have meeting the standards or not. The runout gauges, the load testing rigs, how you are testing it with the help of like software, and also like a hardware testing rigs. Also the CMM coordinate measuring machines, the 3D scanning of the whole the vehicles, all those in under the five pillars, you that inspection, complete inspection of the vehicle, so that you can like scale up, you can show the manufacturers that yeah, this vehicle is ready to produce at a very mass scale. You don't have to of course produce the vehicle at a mass level, but you must show the capability of that vehicle to be produced at a mass scale. Next slide, sir. Now the very important part what Vora sir has already discussed, like traceability and traceability of the product. So whenever you are manufacturing a part, so the traceability should be there. If you are using a part, a small part, so the part number, the batch number, in which batch it has been produced, what material you have used for that, what are the manufacturing details of that particular part. Along with that, what are the what workers have worked on that, in which batch it has been produced. So like traceability of part, it can ensure that like in the manufacturing, whether some in like a small component has been found as a faulty, so like the whole batch can be traced out and it can be like repair immediately. So incorporating those principles are also required while you are showing this manufacturability of your product. And apart from that, like digital, if you have used some digital identification, some smart manufacturing techniques, like to reduce your inventory, to reduce your process inventory, or anything like QR code on batches of, you have procured some product, and just to check them, you have used QR code, or if any QR code method can be used to trace those batches, so those you have to incorporate, you are supposed to incorporate in that. So these things in a totality will show like how ready this product is for manufacturability, and how ready you are uh, to get this product as a at a mass production level in any industry, in any manufacturing give big manufacturing scale. Next slide, sir. So these of standardization principle, what I have discussed in previous slide, like these design standards, process standard. So in design standard, you are supposed to add geometric dimensioning and tolerances, the tolerance stack, and all those things we have discussed. In process standard, you have to add these things, SOPs, jigs and fixture. What in documentation, you have everything, like whatever audits you have done, whatever like testings you have done, all those things. So these are the aspect you have to incorporate during in standardization traceability to show these kind of concepts. Next slide, sir. Yeah, so this is very important to understand. Like if you are going for a manufacturing your vehicle at a very mass scale, and you are projecting that yeah, this vehicle is ready to be mass at to go at a production level. So in that, you have in your manufacturing process, it is very important to show that you have used lean principles and you have used optimization technique. Like in lean principles are basically based on how closely you have worked to minimize your wasted whatever wastage, in process wastage are there during machining. If something you during machining, if you find something part, like this part has been cut down, so whether you have used that part in a different component, and in welding, in other processes also, in every manufacturing process, how you are focusing on eliminating the waste, and you are going for value addition to those value creation from those wastes. So those concepts come under the lean principle. So like the waste reduction, and the in waste in terms of time, or like assets, or energy, in any kind of term, like in transportation, in the inventory, in the waiting, in the assembly line, and during in the also the defect optimization. Like if you have used any kind of Six Sigma or Three Sigma principles, quality in the quality control mechanism, so those things are actually come under the least. Apart from that, also, if you have used Kaizen, like you have understood, like in during the process, you have improved your manufacturing processes. Like in earlier part, you have used a different method, and in upcoming parts, you have changed the strategy, just to you have understood like this particular part is had that problem. So like that process Kaizen, how you are continuously improving as a manufacturer. And also this just in time, like in just in time, it is actually showing like we have no process inventory. Like if you are using any 3D printing technique, which actually produces no inventory is there. If you want the product, you just get it right now. So like those kind of principles, if you have used, you can show that, you can showcase that in your manufacturing excellence, in your manufacturing processes. So those can be evaluated, and a complete understanding of manufacturing concepts will be there through this excellence award. So I think this is the last slide. Yeah. So from this, I'll over to Vora sir.
Yeah, so thank you, Sankata. So what is important is that we have explained you the entire manufacturing process and how can that manufacturing process excel. So by doing so, one, you will learn when you join the industry, and you will also understand that so much of intelligence goes into the entire manufacturing that manufacturing is no more just a third grade job where you blacken your hands, right? And you blacken your dress. It is no more like that. It is a very, very sophisticated way of manufacturing industry 4.0, industry 5.0, where you use the AI, where you use automation, where you use robo. So first, this misconception must go. Second, how can you make things more systematic by doing proper planning, by doing proper documentation, and making one prototype, but then making that prototype with a particular jig and fixture, and then also assuming that you are going to make 4,000 pieces per year, then how are you going to do that? All these things you will learn, and after some time, I am very sure you will come back and say, we enjoyed doing this, right? So you will enjoy the systematic, like when your mother makes a tea at home or any particular dish at home, she does it frequently, and you will find that there is consistency. Tomorrow, if your sister is doing that, you will say, no, I didn't like it. It is not the way your mother has been doing it. So your mother is also using the same process of consistency, right? Which everyone has to learn. So whether you are at home, whether you are in kitchen, whether you are in factory, wherever you go, there has to be a very sequenced way of doing things, a systematic way of doing things, and that is nothing but Kaizen, continuous improvement. And you have to keep on improving your process so that you have a better productivity, lower cost, and better quality, and so on. Right. So this is what we wanted to explain with these 90 slides. I am sure you would have loved it. Maybe it was slightly heavy, especially for those who are not mechanical and production engineer. But if there are any queries, we are here to answer them. You can just raise your hand and we can answer them. Uh, so let us see if there are any questions from you.
Yes, sir. I would also like to add some points.
Sure, sure.
Like definitely while creating the report, also the students from even from different background, they will understood how a manufacturing industry actually works, as you very
Yes.
rightly pointed out. And you are even by preparing the report and observing your report at on these point on these aspects, you will understand like how these industry are getting so much in a working in a so much standard procedure, and you are very much will become industry ready. Up to 10% you will get ready by preparing report itself. So this will
Yes,
very
yes,
helpful for
yes.
all of those participants.
Yeah. So, for example, I have been reading design reports of many team, and what design report we used to get before 10 years and what design report we are getting now. I can see a very big change, right? There has been a lot of improvement in the way the teams are writing their design report. Similar way, we look forward to a very good production report or a manufacturing report from you with all these intended sections, and maybe one day you will be able to refine this, and you can also convert this into a technical paper, your whether it's a design report or a manufacturing excellence report. You may be able to convert it into a technical paper and publish it somewhere in some conferences, right? So we want you to work on this 2-column SAE format, and then maybe in future you can submit your paper in any SAE conferences or SAE journal, right? So are there any more questions? Maybe you can write it, put it in the chat. I think there are questions, so I will go through them and read them. Sir, so one question is from Sudarshan Sonavane. Sir, we have to apply every given point of manufacturing excellence for only one chosen subsystem or entire vehicle like GD&T and material. So minimum one component and system, obviously. But if you can demonstrate for the entire vehicle, that would be great, which will take some time, I can understand. So I would suggest you must take one system and demonstrate that you have used a CNC machine or a 3D printing or a better method of manufacturing, and you have sufficient documents for them to prove that you have done it in a better way, in a manufacturing excellence way, right? What material you selected, why did you select, what tolerance you selected, why did you select, and all those things with proper justification, a good manufacturing excellence report would help, right? So the next, that is, I hope, Sudarshan, you got the answer. And if any of the speaker wants to answer, feel free to do so. The next question is from Henil Rangani. Now, sir, currently we already covered our component in our workshop. So it is necessary to stamp, log and date photos in report on those respective component. Yes, it would be a very good idea to give a part number of that component which you have made. You can, from traceability point of view, you can put a barcode, or you can stamp it, or you can punch some number on it, right? So it would be a very good idea. And maybe even if you are not used a particular manufacturing process, you can do backward. If, since you are already in December and your components may be ready, you can go backward and decide what type of fixture would have been used, what type of process flow chart would have been used, and make them, right? So basically, we want you to demonstrate that how you are going to use and whether you learned it or not. Next is, sir, actually, I wanted to ask that we are supposed to create a complete standard industrial process for the mass production. At the same time, we are supposed to provide evidence of using CMM, CNC, or other advanced procedure, or by evidence, you mean anything else. Yes, so if you have used, say, for example, it can be a simple vernier caliper, which you are used to check the dimension. Say you have made a rod and then you can check its diameter at 3-4 location to find out the consistency in the diameter, then that is also fine, right? But you must be able to record it, you must be able to document it, make a table and say, okay, I have measured at 3 places the diameters and in x-axis, y-axis, and so that's all. So that is what we want you to use. It is not necessary that you have to use CMM or CNC machine, but if you have used it, well and good, right? If you not use it, you must be able to plan for it. You must be able to document it. Teams who have used CNC machine or 3D printing will always have an added advantage to win this award. Sir, we have to apply every given point of manufacturing. Yes, Sudarshan, you have to apply wherever it is possible. Sir, same template for both design report and manufacturing report, or the manufacturing report template will be released? No, it is the same template. Whatever is your design report template, 2-column template, same. But instead of writing design report, you are writing the manufacturing excellence report. Whole subsystem or only one component? So I would prefer one system and their subcomponents. But if you can do it, well and good. If you're not able to do it, you can just do one component. Something is always better than nothing. So if you do some component, you may get some marks. If you do the entire system, you'll get more marks. Okay. So then there is a question from Nikhil Jha. Sir, actually, I wanted to ask that we are supposed to create, I think the question is incomplete. Or, yeah, it has come. So actually, I wanted to ask that we are supposed to create a complete chart. Achha, this is the question which you already asked. And under that, now you are adding. In addition to this, does team practically produce the same fixture that has been used, or just the design of fixture and drawing? So you can, for example, you are making a roll cage and you are doing an ergonomic design. The rule book already says what type of fixtures you have to use. Demonstrate that you use those fixture. And something for mass production, maybe you have not made the fixture, then you can only make the drawing. So your understanding is perfectly correct. Whatever you can demonstrate, whatever you can work on it, forward or backward, it will be helpful. Sir, it is like making a complete system in our mind and as evidence. Can we use digital twin based analysis if like we do not have access to advanced procedure? That's extraordinary. We are talking about Industry 4.0, and now people are talking about Industry 5.0, where you can use digital twin. Anybody wants to talk about digital twin, Ujjwal or Sankata, in manufacturing?
Yes, yes. So whatever I think Nikhil Jha has raised the point. So definitely, like if you are using laser welding and you wanted to show it with the help of a digital twin, that is far more better, because in even in industries they are doing the same. Like they are preparing first of all digital twin of the processes, and then they are going for the actual process. So that's a great idea. You can of course add that.
Yeah, you can create a digital twin and do all your permutation, combination, and experimentation on the digital twin. And that would be a great idea. So the digital twin can be for a product, digital twin can be for a process, and also the digital twin can be on the performance of the vehicle. Then we have Satyam cover. I think, do I see only one person here? How is that? How many people are there, Amir?
Yes, one people with, I think,
So everyone is left?
yeah, only.
No. There are more than, like, not only one.
Huh?
Yeah, but it's showing only
Because
one people. Yeah, it is some, I think
it's
some
no
problem is there.
160. There are total
Yeah, 160 people. Yeah.
164. Right now, total
160
one.
people.
Uh,
Okay. Fine. Uh,
the
okay.
one people actually raised the hand. The
Raise the
one
hand.
people
So,
should, yeah.
yeah,
Okay.
Mr.
He
Bharat
raised the
Arya has
hand.
raised it.
Yeah, Bharat Arya had raised the hand.
Fine. So I think I have read now. I think Ujjwal, you take over and read some of the questions. So the next question is by Satyam Kavar at 2042. Ujjwal, can you
Yeah,
read them?
so so
Or
he
Sankata
wanted to
can read
ask.
it. Yeah.
Yeah, he wanted to ask, like, under inspection and quality control section, what to mention in the gauge calibration part. So I think in gauge calibration part, inspection, you have to show that what type of gauges you have used, like go gauge, not go gauge, or filler gauge, or any other gauge if you have used for inspection, and how you are using it, and for what component you are using it, that you have to show in this inspection report.
Yes. So next question
And
is
for
from Well
next
Durti.
is from Swarna Jyoti. So, sir, some parts are being made in industry, so they will give them CMM report, but we are manufacturing some part. How shall we submit dimension report for those? Okay, so whatever part you have procured from any industry, you can incorporate those report, but of course you should have understanding of that, like how those CMM reports, what they are showing, what they are actually containing in that report. And for those product what you have manufactured in house, for those you have to submit report by yourself using either vernier caliper you have using, or any kind of inspection tool you have used for the product you have already manufactured at your site. Then that you have to do by yourself. And for industry procure product, you can use their reports as a reference.
So for example, if you're buying a product from a customer, from a vendor, right? So in any factory, some portion of the parts are made. So for example, the body in white is made in the vehicle manufacturer's workshop, but the tires, the air filter, fuel filter, oil filter, all these parts are purchased and fitted, right? So then the PPAP procedure is done. The vehicle manufacturer will ask all this report from the component manufacturer. So like that, from some of the component manufacturer, you can ask, sir, can I get a report? Suppose you are buying a battery, then you can ask for a test report. If you're buying a roll cage, you can ask for the material report. So have a practice of getting report, whether they are related to dimensions, whether related to material composition, or they are related to a CMM, or they are related to quality. Ask for a report along with the invoice. That will help you, right? So some of them would positively give, and if you tell them that this is for my Baha event and this is for my educational purpose, I will learn out of it, then they will be very happy to provide to you. Yes,
Yeah,
Sankata.
so
Next question is
next
from Kishan.
question Christian has asked that, so the objective of the event is to simulate the mass production of the selected component. So can we alter our current manufactured design for DFM and make the plan for the updated part? Additionally, there were two sections to add pictures and inspection reports of the component, but the manufacturing method for one part will be vastly different from the method for mass production. So it won't match what is would be okay. So what I understood, Krishan, like of course, like if you are doing the welding process, the same welding will be there in the industry also. Yeah, it might be in the same manner in what you are doing, but the welding process will be there. So you have to think in that perspective. Like for machining, if you are going for lathe machining, or if you are going for CNC lathe machining, so all those from all those aspects, you have to add these things. And you don't have to think like if you are like preparing some part at a very junkyard level, so that particular part will not be a part of that. But for the standard manufacturing process like welding, casting, machining, forging, all those you can do do this exercise.
Okay, I will add something to what you said. I understood your point, Kishan. What you are saying is that suppose you are making one component, you are making a roll cage, then you are making only one roll cage, and how can you use DFM in that? So in one roll cage also you can do design for manufacturing. For example, you do that your driver must be able to sit inside, your driver must be able to jump out in 5 seconds. All those are part of design for manufacturing. And then maybe if you are going to make 4,000 pieces, then you will use a robo to weld those parts. It will go through a conveyor and you will weld those parts. And then other components will be fitted around it. So one is something which you are making. You can make the design for manufacturing of what you have made and the process flow chart for that. And another which you are going to make for 4,000, that you can only do the planning. You need not make it, but you can plan for the entire thing and demonstrate. So you can have two columns, one for the prototype which you have done actually, and one for which you can do it in future if you mass produce this part, right? So you can do it both of them, right? And if you are able to demonstrate that this is how I will mass produce, even though you're not mass produced, it is fine. Basically, the judges want to understand that you have understood the manufacturing excellence. Next
Yeah,
is from Prathamesh. Yeah.
Yeah, so Prathamesh want for the component which we have selected, we have used VMC machining work, but for mass manufacturing, we prefer casting. Is it okay to show or note the process? Yeah, of course it is okay, as Vora sir has told. Like what you have used currently, you also put that, and what you are planning for mass manufacturing, you also put in the same slide. But whatever you are preparing for the mass production, you have to put that part in a highlight, like what I'm projecting for this particular part.
Yeah, there is one
Um,
question on process FMEA. Henil says, as you show process FMEA table in previous slides, can we put different table or any format in any topic? So you have to use a standard process FMEA table that is available on internet, right? You can use them. There could be some deviation is fine, but it cannot be totally different. It cannot be a table which has been defined by you and your team. It has to be a standard which the big three have done it. So you can find that in many documents that what is the table, what are the various columns in process FMEA. So try to use that. We have already put design FMEA and DVP in the website of BAHA. We will also put the process FMEA sheet in the website of BAHA. Okay. So do I have to perform PFMEA on 4,000 units or on only 1 unit? So that is the way you think, right? So if you think that for 1 unit, I'm doing a design FMEA this way or process FMEA this way, then if I'm going to make 4,000 units, what will be the way I do? In my opinion, it would be one and same, right? You can have two options. You can have two row in a design process FMEA where it says that if you make one, this is my process. If I make 4,000, this is my process. So both can be included in your process FMEA. Next, you can read Venkata or Sankata.
Yes, so
Piyush.
Pius has asked when will be the manufacturing excellent PPT template will release? So that you have to announce, sir.
No, there is no PPT. There is only a report. It is a 2-column essay report which you are using for your design report. and the guidelines for the manufacturing excellence is already released. What we are doing today is explaining you more. So use your wisdom, use that 2-column format of design report and convert into the manufacturing excellence report. So that is what we want. There is no PPT. The judges are not going to look at your presentation. Judges are going to look at the chart or the poster, big posters of A1 size, which you are going to bring there, similar to your design report. So no one makes a design PPT when the design evaluation takes place at site. Maybe some of you have not used it because from last post-COVID, we have been doing it virtually in the form of a presentation. But when you come physically, there is no presentation. Those are the charts. You make 5-6 charts and come. And that is what is expected in design evaluation. And the same is expected in the manufacturing evaluation. So I hope it is clear that whenever there is an offline event, there is no PPT. Those are charts. And maybe a hard copy will do.
So Mohammed Asif is
Yeah.
asking that do we have any sample report which will have give better understanding for and
No,
viable
there is no
reference?
sample report, and we do not want to give you a sample report. Use your own imagination, use your own ideas and concept, and make a report. This is the first year. I'm sure you will come out, but a lot of reports are available online. You can use them, but I think use your own imagination, and we'll appreciate if you do something with your own imagination and own wisdom. The judges would appreciate that, and you may tend to get more marks.
So Kunal is asking, sir, can we add supply chain management and AI chatbot for voice of customer? Of course, Kunal, you can do that because Industry 5.0 is completely customer focused. So of course, you can add supply chain management, AI chatbots, and whatever the components of smart manufacturing are there, you can use them, you can showcase them. That would be and give you an added benefit.
But to adding to one point,
Yeah.
like they only have 10 page to cover in the report, or 10 plus 5 additional. So they must have to add all the content first, and then I guess edit this additional things.
Yeah, I
Yes,
think
yes.
chatbot, I think supply chain management and AI for smart manufacturing is already the part of the report. So in that
Yeah.
particular also they can add.
Yeah, you must know how to write in short. Like when you write a summary or an executive summary report or an abstract, in this 10 page, how can you cover? For example, you are in design report, you are covering design of roll cage, suspension, steering, brake, everything, right? So similarly, in 10 pages, can anyone do it? No, it's not possible. It requires 100 pages if you are really doing it. But here also, you have to write in short, how have you done? You don't have to give each and every detail. But when a judge asks, you can explain those details, or you can come with all those evidence. Maybe you can come with a design handbook where you have all those design calculation, which may not be in your report, right? So come with a lot of data, come with drawings, which you can show to the judges. Judges will be happy to see that, and they will not be happy to see your laptop because it's very difficult in sunlight to see all that thing. So the next question is on so Vivek says that it is necessary to provide GD&T of that subsystem because our design process is completed. So even if your design process is completed, for example, you have a press fitted part, then what was the limit and fit? What was the using GD&T? What tolerances have you used for the male part, female part? All those things you can write it down in your manufacturing report. That is very important, even though you must have not used it, but I'm sure one of your colleague must have used it. So please document that. Even then, if you're not used, then you can use it for mass production and you can put that in your report, right? So you can be very clear that this is for one prototype, we have used this process, and for 400 parts, we will be using this process. You need not demonstrate that you already used for 4,000 because you have not actually made it. Then, sir, while manufacturing a particular part, there will be some amount of material will be waste. So for that also, do we have to provide a solution? Yes, obviously. So I think one of the last few slides of the speaker, he said that if you can reduce the waste, that is also one of the excellence in manufacturing. For example, you are using a stamping and you have a big sheet and you are making only one part. You can make 3 parts into this in a different format. Then you are saving material. Or you are using that material, the scrap material, somewhere else then for making, for example, an impact attenuator, then that is also a good idea. So you can reuse, recycle, or reduce whatever way you want while manufacturing. And then we have some more question. This is from Swarna Jyoti again. Can you read? Sir, for the CMM report, are we supposed to include all reports in 15 page or shall we create a separate doc for this? What do we say? I think that can be an annexure. For CMM report can be an annexure. And if you are not able to add everything in this 15 or 20 pages, you can bring it with you, those report, and show it to the judges physically.
Yeah, so next question is from Akhilesh. Sir, please tell us more about statistical quality control and how we can implement it in our quality control checks. So we have only you can say the report is as already it has been told the format of report is in a you have to provide all those information in a limited manner. So if you will focus more on statistical quality control, you will lose your focus towards the other aspect of manufacturing. So what I'll suggest that yeah, of course you will put some points over quality control, but do not completely focused on quality control. You also include all those important aspects as well.
Yeah, the next question is from Leah. It says, so for all presentation event, I'm not talking about all the present, we are talking about the manufacturing excellence event. So for design event, for sales presentation, there are different rules and there are different guidelines which has been provided to you. Read those guidelines and according, don't have any misunderstanding that we told you for that no PPT is required for all. So that we leave it on you depending on how do you read those guidelines. Next is from Kunal.
Yeah, so
Can you
it
read?
is, he can say, he's saying, sir, can we prefer other industry production planning? You can refer anything you want, but of course it need to be a standard format. It need to be in a industry aligned manner, and of course you stick to the whatever guidelines has been provided by the SAE BAHA. So you can under that you can refer anything you want.
Yeah,
But
next, Anil. Anil?
next. Yes, sir. Next is from Rangani. As I mentioned in guideline that the material selection logic using tool simulations. If we have only hand calculation, can we put direct calculation without using? Yes, like hand calculation is the basic. We call it as a design by using first principle. So of course, design using first principle must be there if you are finalizing any design. The design before the analysis and all those things, design calculation by first principle is almost required in any every industry. So
Sure.
you should incorporate it in your design report and not in manufacturing report, of course.
Yeah, so I'll add something more. When we say design selection logic using tools and simulation, many of you or your colleagues must have used ANSYS Granta. That is a part of Go Green, where you use ANSYS Granta to reduce your carbon credits. And that is possible by choosing material which helps you to emit less carbon dioxide. So that is also the same tool. So ANSYS Granta is one tool which can help you in material selection. Next, by Prithviraj.
Yeah, all the mandatory sections are not fitting for any part in the vehicle, not the one who is choosing. So can we add the possible sections only which are suitable for the part, or compulsorily they have to add as per marking scheme?
Yeah, you
I
can,
think
I'll answer this. You can,
okay.
whatever is possible, you can add. It is not necessary to add everything, but you have seen the mark criteria. There are 8 criteria. If you use that 8 criteria, then you have chance of getting more marks because the judges have 8 columns and they have to write the marks. If you have not done anything in that particular area, then he will give you 0, 1 or 2 out of 10. So please be a jack of all, ensure that every part, every criteria you have answered so that you tend to get more mark, right? So that's academic, but what is important is we want you to learn this process.
So
Next.
next one is, sir, apart from the prescribed 15-page report, is it permissible to bring a consolidated file of our own documentation checklist and supplementary reference list for the evaluation purpose?
Yes, you can positively do that. That is something which is very preferred. When the judges are doing design evaluation, we see a lot of students coming with their design calculations or all 2D drawings which are what do you say, bound together. And when we see those A3 size 2D drawings, we really love it and we tend to give more marks. So please bring all the documents which you have. And that would be a great idea. Like in sales presentation, I've seen some team coming with the plan of the entire factory made in thermocol or cardboard or something. Similarly, you can do this also, and you can bring more documents to be shown physically to the judge.
Yeah,
And I
next one
think
is
the
from
last question.
Satyam. Sir, how to make process sheet for roll case? Also, sir, how can we add the standard PFMA from in a 2-column SAE format?
So your report need not be in a 2-column format. It can be a attachment to your report. So you can separately give the process FMEA. So maybe along with that's a very good question, Satyam. Along with design report, that is 10 plus 5 or 15 plus 5, you can give separately process FMEA. We will ask the organizers to allow you to everyone to submit process FMEA documents separately. Okay. So we will do that. It's a good question.
So, next question is, please explain tax time estimation and bottleneck identification, especially in our case, like in the vehicle manufacturing.
Yeah, I think we will not be able to answer each and every question. You can go and find out this answer on internet. And if you are not able to find out, you can just put this question on the forum and somebody would answer it, right? So I think the questions were extraordinary and a lot of questions. We are very happy to see so many questions. That means you have doubt and you have a desire to understand this difficult process which you are going to do it for the first time. So we are very happy with all your questions. Probably this will become the future FAQs. अमीर जी आप ये सब questions जो है वो आप copy कर लेना. We will in future we can use it as an FAQ for the students. And we have tried our best to answer this question in our individual capacity. But I think you can do more study. Also, there are books available in manufacturing which you can go through, and you can also visit some factory and then talk to them, especially the vendors who are supplying to automotive companies who make small parts. If you go to Chakan or Bhosri in Pune or in Coimbatore or Rajkot, wherever you are, I'm sure in those areas there will be small scale industry, MSME. Visit them, find out how do they do PPAP document, those 18 documents, find out how do they do documentation, find out how do they do inspection. Then your learning would be much better than what we are teaching you through this presentation. So visit to a factory would really help you. One more question. Yes.
Yes, I think yes has asked manufacturing process of project scope and problem statement is different. Do I need to show them same or go different?
I didn't get the question.
Sir, he's asking the difference like we in manufacturing process and project scope of the problem statement. So I think you have not understood the slides. You can go the guidelines once again. And what is like we are more focused on what is the manufacturing process of your vehicle, whatever routes you have used, whatever processes you have used, whatever principles you have used in the manufacturing process, those you have to incorporate in that report. And the
Yeah,
next
one more.
question
Yeah,
is,
yeah,
yeah.
Go ahead.
With respect to subsystem development, are teams to required produce every component themselves, or can certain non-critical parts be outsourced while we focus? Of course, we have answered these questions. Like if you are procuring these parts from any other industry, you can submit the report from whatever you got from those industries. And if you are manufacturing any part in-house, you can add all those necessary thing in that report.
Yeah, it is your decision of make and buy, right?
Yeah.
So once you decide what you're going to make in-house, and once you decide what you're going to buy from outside, you don't worry about what is purchased outside. If they can give you a report, it would be great. but you concentrate in what you are going to make inside, and for that you ensure that the entire process is followed.
So Raj is asking, will the page having name of captain and his contact, which has to be included on the? I think these questions, these Baha team will of course answer you, like how you are these on the guideline of the how to submit these report. On there itself, it has been written like how to prepare
So
those reports.
I will give you an answer to that. If you see a
Okay.
design report, the design report writes after the title of your design report in the name of the college or the team, you write down the name of the authors. So if say three of you have worked on this, the entire team does not work. Some will work in design, some will work in manufacturing, some will work in making a vehicle, somebody will work in marketing and getting sponsorship. So the people who have worked on this, you can write those three names in the name of the author under the SAE format, right? So you can, that is fine. It is not necessary to write the name of the captain. You have to write the name of the people who have worked on it or who have made the report.
Next is from Abhijit. Sir, can we focus on different parts of different subsystem rather than selecting a particular subsystem?
Sure. You can do that. You can do that. You can take one subsystem and design all the parts, design the manufacturing of all the parts, or you can take different parts, whichever you have manufactured, they can be of different subsystem.
I think that's all, sir.
Yeah, and then last question. So regarding the 15-page report
Okay.
structure, can image and figure be integrated within the main? Yes, if it is within 10 pages, then it would be a good idea to put the text, image, picture, photograph, everything into that. That means instead of 10, you can take 15 pages also. Or you can do a 10-page text and 5-page pictures, whatever way you like, right? So you can do that. I think we are not very fussy on that. What we want to tell is don't make a 30-page report or a 50-page report that judges will not get time to read. It's you understand that judges will have to read so many reports and then understand them and then come at the site when you're going to show your vehicle. So here also you'll have to show that vehicle. You have to come with your vehicle. Like for design report, you always when you come with your vehicle. For manufacturing also, you will have to come with your vehicle and then demonstrate that, right? Okay, I think very good questions, and you are tempted to ask more and more questions. That shows a very good sign of learning, and life is all lifelong learning. So keep learning, keep smiling. Thank you very much, and we are on time. It is 9:10, 10 minutes overshooted due to the questions. Thank you very much. From the bottom of my heart, I will thank all the team members to join us and listen to this presentation. And I also thank both of my speakers, colleagues who have been associated with this event. Thank you very much.
Thank you. Thank you all.
Okay, Amir, we can close now. Amir? Okay, I'll take leave.